Question number 42 on the trigonometry final review. Find all the complex roots. Leave your answers in polar form with the argument in degrees. The complex cube roots of negative 8i. We have a formula for the complex cube roots for the polar form, and I put that right below. The nth root of r times the cosine of theta over n plus 360 degrees times k over n plus I sine the quantity of theta over n plus 360 degrees times k over n for k equals 0, 1, 2, continued until you reach the value of n minus 1. Because we're evaluating the cube root of negative 8i, we know that that's going to be a 3 in the place of the n value with the r underneath the root. So we have n equals 3, and 3 minus 1 equals 2, which means we're going to be solving for k values 0, 1, and 2. So we'll be using this formula 3 different times. From there, it's best to go ahead and draw your number. It's best to draw your imaginary number. So I went ahead and drew negative 8i, which is going to be down 8 on the imaginary or y-axis. We know that the negative portion of the y or imaginary axis is equivalent to 3 pi over 2 or 270 degrees. So from there we were able to evaluate n equals 3, r equals negative 8, and theta equals 270. So in the step right below, I went ahead and filled in those variable values to give us an unsimplified version. So we have z of 0 equals cubed root of 8 times cosine 270 degrees over 3 plus 360 k over 3 plus I sine 270 degrees over 3 plus 360 k over 3. In this case, we know that k equals 0, so we can go ahead and get rid of these 2, which leaves us with z of 0 equals 2 times cosine 90 degrees plus I sine 90 degrees. For the second trial, which is k equals 0, we've got z of 1 equals the cube root of a times the cosine of 270 degrees over 3 plus 360 degrees times 1, the k value, over 3, plus I sine 270 degrees over 3 plus 360 degrees times 1 over 3. When we simplify, we get z of 1 equals 2 times the cosine of 90 degrees plus 120 degrees plus I sine 90 degrees plus 120 degrees, which ultimately gives us z of 1 equals 2 times the cosine of 210 degrees plus I sine 210 degrees. And finally, we are on k equals 2. So z of 2 equals the cube root of 8 times cosine of 270 degrees plus 3. Z of 2 equals the cube root of 8 times the quantity of cosine 270 degrees over 3 plus 360 degrees times 2 over 3 plus I sine 270 degrees over 3 plus 360 degrees times 2 over 3. When we evaluate, we get z of 2 equals 2 times the cosine of 90 degrees plus 240 degrees plus I sine 90 degrees plus 240 degrees, which finally gives us z of 2 equals 2 times the cosine of 330 degrees plus I sine 330 degrees. You saw me adding in those parentheses there because you want to be sure that you have your parentheses set up so you don't forget that you want to add those angle measures together. So when you present your answer, you're going to want to present all 3 values for k. So we have z of 0 equals 2 times the cosine of 90 degrees plus I sine 90 degrees. z of 1 equals 2 times the cosine of 210 degrees plus I sine 210 degrees. And lastly, z of 2 equals 2 times the cosine of 330 degrees plus I sine 330 degrees. Thanks for watching.